We are currently living in an information era where there is an exponential increase in data and information transfer. And we are currently facing the limitation of the electronics technology. So we are exploring new technologies to overcome this hurdle, and quantum technology and photonics can offer a solution here. The potential benefits of photonics and quantum are that not that they can fully replace the electronics technology, which is currently widely being used, but that they contribute to the more sustainable society.
With the development of photonics and quantum technology, we've made quite some progress, but there are also many steps ahead. And I think the really interesting challenge for us now is seeing how we can sort of cross-fertilize those fields, work on technology development, but also on meaningful applications with industry and societal stakeholders to really maximize the impact these technologies will have on our society. So here in Eindhoven, we really already have a lot of experience with photonics development and commercialization. And the field of quantum can greatly benefit from that.
Photonics and quantum are both technologies that have been around for a while, especially photonics has been used in the industry, in communications especially for a long time. Quantum is more up and coming, and photonics is something that really enables quantum. And if we can link them more closer, we can actually make quantum technologies reality much quicker than we could otherwise. And for myself in telecommunications, especially quantum key distribution is basically enabled by photonics. So basically we use photonics and quantum to bring them together to make both more realistic, more valuable technologies. Quantum technologies have a lot of benefits that are yet to be explored. If we're then looking beyond quantum computing, quantum sensors, and of course quantum communication to link those sensors and those computers are big things that can really revolutionize what our society can do, especially if we look at the new computing paradigms for quantum computers.
At the Brainport region, we believe that triple helix collaboration is key for ecosystem development. So in this region, industry, knowledge and educational institutes and government work together on ecosystem development. We also do this on the theme of integrated photonics and quantum technology. And here, the Eindhoven Hendrik Casimir Institute is one of the leading partners. An important challenge is to make the translation between research to business opportunity. The university in Eindhoven is well known for its industry cooperation. So the Institute is well positioned to make this translation. So first of all, do a lot of research for several of years, because that's still needed, but then also make the translation towards business opportunities.
Yeah, so we're building a big testbed for quantum key distribution, for quantum communications. We're actually working with a number of local partners around Eindhoven and of course within TUE, within EHCI, to build a testbed facility. So meaning we're trying to use existing quantum key distribution technology to put it out into the field.
As a PhD, I'm taking initiative of teaching through challenges, something called challenge-based learning, and they really help me into building these relationships with companies, with students, and they are really eager. I would say it's the power and the potential that they have to have less energy. It's more energy efficient photonics compared to electronics, even in quantum. Also, all the potential capabilities that we yet don't know that they have and that we can unveil studying this and making this research. And also all the applications that even we can see in our daily lives. I think that entrepreneurship is how we can make the biggest impact in the world, and I think that photonics has the power, the capability to do that. And that's how the Hendrik Casimir Institute, I think, that merge both things.
So for the future, we see many more partnerships and collaborative innovation happening with the various stakeholders as part of the Hendrik Casimir Institute. For example, partnering and co-creating with hospitals, doctors and patients to uncover new medical applications, partnering with big tech companies, for example, to make more energy efficient data centers, partnering with farmers to co-create new agricultural smart farming solutions. We collaborate with many industrial and societal stakeholders in really bringing out, unleashing the potential societal impact of photonics and quantum technology.
I think there's a few things where we can bring quantum and photonics together, like quantum key distribution, where we might see the first actual real-world deployments in the next, let's say, decade. If we look further towards the future, quantum computing, quantum sensing, and more advanced quantum networking, the quantum internet, we're probably looking a few decades out. Obviously, we're here to try and accelerate that work.
Our purpose, I would say, is to keep feeding newly developed technologies within the integrated photonics and within the quantum technologies into industry and into society. Now is the time to work on those two different fields, to connect those, and our institute is the ideal environment to look for opportunities to connect those technologies.